Good afternoon, ladies and gentlemen. A warm welcome to the webinar on utilizing iiRDS in companies. We're so much delighted to have you here, joining us for this insightful and I'm quite sure delightful session organized this time by tekom Belgium. My name is Justina Dujok, and not only am I a proud member of tekom Belgium, but also your moderator for the session. Alongside me is my colleague Birgitta Meeks, who is a delegate member, part of the initiative committee. And we are also very happy because we're celebrating 10-year anniversary. Birgitta is waiting here. Allow me to get straight to it and introduce our distinguished presenters for the session. Firstly, we have Ulrike Parson, the founder and CEO of Parson AG, renowned for her expertise in content strategy, intelligent content, developer documentation. As many of you probably know already, she serves as an acting chair of the iiRDS steering committee, and she is joined by Dr. Achim Steinacker, director of delivery and operations and Empolis Information Management. He himself brings a wealth of expertise in metadata, models, semantic technologies, and the star of the show, which is the iiRDS. Before we dive into this interesting presentation by Ulrike and Achim, I just want to highlight that this presentation is recorded, and we definitely encourage you to ask questions. Not only that, but actually give some insights from your own practical experience into the chat box that you see and go to webinar. Also, we will be having some use cases, and after each use case, Achim and Ulrike are very happy to answer questions. As I said, the engagement is so crucial in the webinar. This is exactly what makes it successful. And since we have this great opportunity with experts, Ulrike and Achim, I think we have to make the most out of it. So without further ado, please welcome Achim, Ulrike. Thank you, and please take the floor.
Thank you very much, Justina, for this great introduction, and welcome to all of the participants on this wonderful afternoon. We have snow outside. I hope it's convenient for you as well and comfortable inside. So what are we talking about today? We are talking about iiRDS, and this is the third webinar in a row of 3 webinars about iiRDS. And today we are coming to the practical use cases of iiRDS, how to actually use the standard in companies and how to use it together with knowledge graphs. I don't need much of an introduction because this was already done. Just one correction, I'm no longer the chair of the steering committee, but just a normal member. Because I gave this role to a colleague of mine from SEW, who is very active now as the steering committee chair. Parson is one of the founding members of the iiRDS Consortium and has been with the consortium from the start. And now to you, Achim.
Okay. Yep. Hello all together. My name is Achim Steinacker. Also, a small correction, I'm not a director of delivery and operations anymore, but a principal consultant, but it's really not important because up to now I'm doing just the same every day. So we'll see if some days not only the title changes. As I was introduced, I'm working for almost 25 years now in knowledge graph-based projects for the industry, defining metadata models. And I'm a convener for the iiRDS working group, tools and validation.
Okay, let's have a look at the agenda. We have 4 main blocks. We will first give an overview of iiRDS very shortly because there have been 2 previous webinars. But for those who couldn't be, weren't able to join them, we wanted to do a short introduction to the standard. Second, we want to talk about knowledge graphs, what they are and how they are used in companies. This is Achim's part. And then we will present 4 use cases with the practical application of iiRDS and knowledge graphs. And there will be time for questions after each use case. That would be my suggestion. And of course, after each of those 4 agenda points. And last but not least, would like to summarize all the things that we learned from these projects in 2 slides, and then there will be room for your questions that you haven't asked in between. I will try to take a look and keep the question panel in my eye, or in the corner of my eye, and otherwise you're also free to raise your hands. Okay, let's start with a short overview of iiRDS for those who haven't been able to work with the standard yet and who haven't been able to attend the other webinars. So iiRDS is an industry standard which is maintained by the Consortium, also named iiRDS, and the members of the consortiums are industry companies like Siemens and SEW, software manufacturers like Empolis and also Kronos, and consultants like us. iiRDS, the name itself stands for Intelligent Information Request and Delivery Standard, and it's a standard for delivering smart content from technical documentation to a delivery platform. So it serves the transport way between your authoring environment and your delivery environment. Technically, iiRDS has 2 components. It features a delivery format, which is a zip container, so a package. And this package contains a fixed folder structure with the metadata and the content. And all applications that understand iiRDS know how to unzip that format. The content format is flexible, but the metadata must be in RDF. And that brings us to the second component of iiRDS, the metadata definitions. iiRDS is an ontology that contains a vocabulary for technical communication. So it's standardized metadata for your technical documentation. And for actually technically expressing this metadata, we use RDF, which stands for Resource Description Framework, and is a standardized format for describing metadata. iiRDS has a lot of standard vocabulary, but it also offers extension points where you can plug in your own ontologies, for example, for your product metadata. iiRDS has several goals. When we started 2016, we thought it would be a great idea to have a common format and a standard which is independent of manufacturers and IT systems for actually delivering technical documentation to delivery platforms. And we wanted to standardize the metadata vocabulary because there's a lot of metadata that is used across all technical documentation, like information type, document type, target audience, stuff like that. And iiRDS offers a standardized vocabulary for that. We wanted to deliver an extensible standard. That's why we opted for RDF as technical format. The iiRDS Consortium regularly synchronizes its activity with other standardization bodies for the IoT, Industry 4.0, or the product world. Examples are the E-Class Consortium, for example. E-Class is a standard for product data. And last but not least, the consortium provides not only the RDF files with the metadata vocabulary, we also provide tools. One is the iiRDS Open Toolkit, which you can use to generate iiRDS packages from source data like PDF. And the second is a validation tool, which you can use to check your iiRDS packages, whether they technically conform to the standard. And currently a new action started, which will deliver for the R part of iiRDS, the request part, because they started to define the API for requesting iiRDS data from a delivery environment. iiRDS is no authoring standard, so we just standardize how content is packaged and then delivered from the authoring system, how you write that content and which metadata you actually use in your authoring environment. That's your business. Usually the RDF metadata is not written by hand, but created by transformation scenarios or scripts that take your source metadata and map them to iiRDS metadata. iiRDS is not a presentation format. So when you take an iiRDS package, deliver it to a delivery platform, then this platform is responsible for unzipping the package and importing the content and the metadata and presenting it nicely. How this delivery platform stores the content and the metadata, that's also not in the scope of iiRDS, because this can be done differently in different systems. Let's take a short look at the metadata that you have in iiRDS, because we will come back to some of these classes in the use cases. So most of the metadata that we have in iiRDS refer to information unit, because an information unit represents content. And the content can be a complete document, so you can assign metadata to a document, or to topics, or to fragments, which are parts of documents. And then we have 4 main classes for metadata. And the first one is the information type, which tells us which sort of information we are dealing with, like are we dealing with a task description, or are we dealing with a troubleshooting topic. The second one holds subclasses for product metadata. There we have something like components, product features, product properties, and product variants. So this is one of those docking points I mentioned. This is where it's just classes and subclasses. There is no instances in there, and no metadata objects, because this is where you usually plug in your company-specific metadata. Then we have the functional metadata, which contains metadata classes for target audiences, for supplies like tools and spare parts, and also for events. And last but not least, we have the administrative metadata, which may indicate who's the author of the content, who's the company responsible for the content, and also which status does the content have. Okay, and now, after this short introduction, we go to knowledge graphs, and you need to share.
Thank you. Okay, what do I share at the moment?
I see the red slide, knowledge graphs and companies, in presentation mode, so that looks good.
That's perfect. Thank you, Ulrike. So knowledge graphs and company. In companies, what is a knowledge graph? What does it have to do with AI? Just some short categorization. You shouldn't expect it with all the generative AI, ChatGPT, statistic, machine learning AI hype, especially this year. But all this machine learning, statistic, or black box AI is just one part of the game. And the, well, more or less traditional knowledge-based AI, where it's about real facts, where it's about reasoning, where it's about logic in the programming, is still a very important part in the AI landscape, which is mostly built manual, which is built to do some real reasoning, which is built to explain results and retrieval. And semantic networks, ontologies, or knowledge graphs are an important part of this knowledge-based AI. And a knowledge graph is more or less just a different kind of storing information. You can't store anything that's also not possible to store in a relational database. It's just another way of presenting. It's just another way of modeling. When you're using different type of nodes, in this example for person, Anna is a person, and different kind of connections to connect these nodes together to form a graph. And in this small example, Anna works in a project. and this project has a customer. So 3 different type of nodes, 2 different type of connections, and this can be extended in any possible way. There can be more projects, and Anna and Peter, they work together in the project, also in combination with the Universal AG. And this project probably also has some topics it's dealing with, and just with a small example, you can see how you can already do some reasoning on this graph. For example, you can see that the project FIRE, the Universal AG is the customer, and the Universal AG has the branch retail. So you know about the branch of the project. You can see that Anna is working for the analytics team, and so it's quite easy to traverse the graph and to see that the analytics team is dealing with projects of the retail branch, and also that the project FIRE has something to do with artificial intelligence, because main topics of these projects are semantics and machine learning, and those are both subconcepts of artificial intelligence. So this is just a small example where you can see that it's easy for humans to understand the model. It's easy for humans to maintain and extend the model, and it's also easy for machines to understand this model and to reason and to find new knowledge when traversing the graph. And this was just a small example. In the real world, those graphs are getting a bit more complex, they're getting a bit larger, and most of the time they're representing product models, product properties, product functions. And so in this example, you can see the Heavy Tools company as a manufacturer of 2 different machine types. And those machines, those product variants, they do have a bill of material. It's quite similar, the PowerMold M3000 to the PowerMold M5000. They are probably they are sharing some components, but they also do have components which are special to them. And if you had a look at the picture Ulrike showed you a minute ago, you can also see that component, that manufacturer, that things like sensors are also part of iiRDS. So iiRDS is able to build a connection to these product models. So iiRDS is also able to attach information to this graph, to attach information, for example, to an error code EA342, to an explanation why this error code can happen at a component in the PowerMold M5000, but not in the PowerMold M3000, because it's using a different cantilever in its bill of material. And this is, you do have a model about your product, about your functions, about your properties. You can reason about the errors and error codes and the things you have to do if an error happens. And it's quite easy because you can also attach those topics using iiRDS metadata to a knowledge graph representing a product model, because that's a knowledge graph representation of an iiRDS topic. Cleaning the rotor, you can see the language, you can see the document types, you get information about the life cycle status. Also, you can see in which document structures this topic is used, and you have the connection to the product metadata. In this picture, just the product life cycle, but there can also be relations and connections to product models, functions, components, and error codes, or whatever is used by your technical documentation. So knowledge graphs are understandable for humans and machines. Big advantage of using this kind of data model. The most important knowledge required for a really smart information delivery is based on the context of the information. Information is more or less useless if you don't know about the context of the people requesting the information, if you don't know about the target group, if you don't know what they want to achieve with the information. And using this connection between information combined, connected with metadata is even more important than the actual content itself. You can use one data model for all use cases, as you can represent all kind of data modeling approaches like relational databases, hierarchical databases, whatever in a graph. You only need one data model to represent all these data and all the use cases. It's easily expandable. If you're missing a type of node, well, just add it. If you're missing a few connections, just add them. And you can use the new model without making any changes to the old one. The rules applied to this knowledge graph can be, it's a definition of rules. It's not hidden in the implementation logic of code. It's much easier to maintain, and again, it's much easier for domain experts to build their own rules. You don't have to be a programmer to query the graph to define new rules. And because the data model itself is the information, it's not stored in the actual content anymore, just shifted to a higher metadata level, where the essence of the information is stored in the graph, and the information is just presented to the user when he performs a search. It's the perfect technique to integrate data from different sources. And as a spoiler to one of the use cases we will present in a few minutes, it's a perfect addition for the usage of large language model. So as you've seen, the example was a product model, and the usage in product scenarios for product configuration and the intelligent delivery of product information is one of the main use cases in the industry at the moment. It still helps with information retrieval, and as we will later see, also for the building of digital information twins. It can be used to automate the mapping of different product classification schemes. Daily pain in the industry. They are using their own product classification. One supplier wants to have it conforming to the E-class specification. The other one is providing information and is using ATIM as a product classification scheme. And all this mapping and all the rules to automate these mappings can be defined using a knowledge graph. And if you can use it to automate mappings, you can also use it to harmonize your metadata. The metadata used in authoring system can be found and mapped to the metadata used in PIM system or ERP systems. And so the knowledge graph is the perfect technique to build a harmonized master data model for the company. So these were some introductive thoughts to iiRDS in general and to knowledge graphs. If there are no questions yet, I would continue with the selected use case.
Shall we wait 2 seconds if anybody has a question?
Yeah. 3, 2, 1. Thank you. No. But it seems like there's no question yet, so I will present the first use case. Well, and the first use case is basically the main goal of iiRDS. Publish technical documentation, service documentation in a content delivery portal or service. Provided as self-help to staff and customers, and a bit more complicated, extend the existing iiRDS metadata with models from other domains to support extended use cases. I mean, iiRDS provides a basic vocabulary. iiRDS is not supposed to to cover all world aspects of documentation. It's a base, it's a backbone, and there are still a lot of use cases which need some more detailed model. And we will also present an example where this was used to extend iiRDS. And the setup for the solution is quite easy. Just use it as a transport structured content and metadata to a content delivery portal or system. So what is iiRDS, and especially the metadata, is used for in the delivery system or in the delivery portal? It's mainly used for building facets, for building filters and synonyms in the portal to support a detailed search and retrieval, and also to generate and recommend related content. And as this is well, the most simple and basic use case of iiRDS, there are already a lot of companies using iiRDS as transport medium for their information flow, and these are only the ones I know about. And to just give you an easy example how it works, let's search for a hydraulic pump. And what can we see? And this is just a base content delivery portal able to import iiRDS and to use the metadata. And as you can see, the metadata from the iiRDS is used to build the facets, to filter your search. It's also used to build a knowledge graph out of the metadata. So we know it's about a component, a hydraulic pump. We know, sorry about something still in German, where this component is used, in which kind of product variant. We can have a look at the knowledge graph itself in the back of the system to navigate through the model, to look at different kind of informations, to find your way around. And finally, when you decided, okay, looks like this is the kind of information I want to see, you can not only see the real content, which was transported from the authoring system to the content delivery portal. You can also look at all the metadata. You can navigate through the knowledge portal again. You can use it as a filter. And also the metadata is used to make suggestions for related content regarding the product lifecycle phase, regarding the target group, regarding the component, which might be an additional interesting information when you have the problem with the system maintenance of the hydraulic system. Getting a bit more specific, we will want to present you another use case implemented by the German consulting company ICMS for an Austrian manufacturers of ropeway systems, and also providing and offering an own management system called Claire, responsible for the full maintenance of the resort, not only the ropeway, but also these excavators dealing with the snow, looking for the tickets, whatever you need to know, whatever you need to manage when you're running a whole resort. And they build a digital twin based on a knowledge graph with a full generic resort reference model. So everything what's possible in a ski resort in the Alps or wherever is modeled as a knowledge graph. And they also modeled the full maintenance management in a knowledge graph. And they did this as an iiRDS extension. They just used the docking points already available in iiRDS to specialize and to further detail the model. And therefore, it can easily be transported to the authoring system and used by the authors to annotate their content and their topics. And then the standard iiRDS export can be used to deliver this information to a content delivery server, providing information for the resort management system, CLAIR. So the service technicians walking around the resort all over the day, they do have a UI where they can watch every aspect of the resort at the moment, and they are able to access all the detailed maintenance instructions, all the detailed maintenance tasks, all the detailed repair tasks, and also a list of things they have to do on every part and in every location of the resort. And so they have access to a list of tasks they have to do. And when clicking on the tasks, they will see the topics, they will see the instructions. And these instructions are directly from the authoring system, just annotated with iiRDS metadata, transferred to a content delivery server, and then provided via API to this resort management system. So the role of iiRDS in these use cases is just to enable system independence. As you've seen with Doppelmayr, authoring system from one vendor, knowledge graph-based delivery service from another vendor, and the actual touchpoint system consuming all these information is built by a third vendor, Doppelmayr itself. So there's absolutely no vendor lock in the information flow. iiRDS serves perfectly as a docking point for connecting this modular information with a full digital twin and building a full digital information twin. And you don't need your own portal if you're dealing with iiRDS. It's useful for any possible touch point. And as Ulrike stated a few minutes before, the upcoming request API standardization will even make it more easy to access iiRDS, build metadata and information in a standardized way. The learnings from the project is it works, and it works out of the box. And all the work you've done when authoring and annotating the content can be used directly as facets, as filters, as recommendations in any delivery system and any delivery portal. So whatever information model any possible touch points requires, iiRDS annotated content will be able to provide it. Ulrike, your turn.
Thank you. This is the time for questions while we are switching the moderator here.
No questions so far. Huh.
Do you see my screen?
Yep.
Great. Okay, let's go to the second use case. We now turn our attention to the authoring system and see how we can implement iiRDS in an authoring system. And this is from one of the iiRDS pilot projects. If you don't know yet, if you want to use iiRDS and implement it, you can apply for a funding by the iiRDS Consortium, which gives you €5,000 to start with iiRDS, which you can spend in cooperation with one of the licensed iiRDS consultants. And this is a project that we did together with the Danish manufacturer Danfoss, and they wanted to switch from document-based authoring to topic-based authoring and wanted to introduce in the new component content management system for that. They opted for Ixiasoft because it supports DIDA, and Danfoss wanted to put their focus on standards and have a standard both for the content and for the metadata. They want to switch from documents to topics because once they have implemented content delivery platform, which they haven't done yet, they want their customers to access relevant product information fast and easily. Right now, their documents are for one complete product line, but they want to make the documentation more specific and want to create documentation or information products that are specific to a single product variant. So the customer only reads the documentation that applies to their product variant that they are using. And internally with the CCMS, they wanted to increase the reuse of content between their product lines. So the solution setup technically is rather simple. We have a data-based CCMS, we have iiRDS metadata, and we set this both up and then tested it or prototyped it with some sample content. So the first thing that we did while Danfoss was getting familiar with Ixiasoft was setting up or developing a metadata model based on iiRDS. And when you set out to do such a thing, you have to define which of the iiRDS metadata you want to use. It's one of the good things about iiRDS. You don't have to use the complete model. You can focus on what you actually need for your use case. And to find suitable candidates for metadata, there are different angles from which you can start that. And the first angle is that you take a look at your documentation variants. Usually documentation variants are caused by product variants. They may also be caused by different target audiences, but usually when you generate information products from the same source, when you do single source publishing, you need to do variant management based on products. And this was also true for Danfoss. They have the things that decide about their documentation variants are components and the properties of their functions, like the power range or the voltage range. So these were, this is metadata that we can use to differentiate between the documentation variants. And as you can see, they come from the iiRDS class of product metadata. Then the second angle that you can use is to take a look at the content delivery requirements. What are people that use your product are actually searching for? In the case of Danfoss, people were looking for troubleshooting information for specific alarm codes. And they also look for typical actions like assembling or cleaning that are described in task topics. So here we have two more metadata ranges that we can use for our model. And then the colleagues also analyzed what metadata is already used in the current CCMS, and we found out that documentation variants are also distinguished by audience and by country, so regional information. What we did then is, and this is one example, the one use case that works without a knowledge graph is to use a mind map template that we have, where we have all the iiRDS classes inside already. And then we take the results from the research I described before and try to fit in the metadata that we need into the iiRDS model. The good thing about it is that you don't need to know about ontology modeling. You can just use this mind map as a basis for discussion with the customer. And here you see that some of the communication and comments that our colleagues exchanged with Danfoss. Based on the discussions, we created the initial metadata model. And if you are trying to put your metadata in an iiRDS model, you have to consider different factors. The first one is try to find the classes that already fit your metadata requirements. So if you have a target audience, you can use the skill class in iiRDS. If you have components, you can use the component class in iiRDS. If you have a specific topic type or a document type, try to find it in iiRDS and use the existing standard metadata as much as possible. If you can't find, like, for instance, a document type that you need or a topic type, just take the matching parent class and add a new, or the matching class and add a new object inside that class. So you can, for instance, easily add a new topic type in the topic type standard class. And if this is not enough, you can also create a custom class and extend iiRDS in that way. The only thing that you need to consider is that your custom class is below one of the 4 standard classes that I showed you before. So this is how you base your metadata model on iiRDS. This is the result for Danfoss, and as you can see, we fit all the metadata that we need within the 4 classes of product metadata, functional, information type, and administrative metadata, and we label them accordingly, depending on whether the metadata is used for variant management or for content delivery. And we also labeled the source, and as you can see, there's different sources for product metadata, which is the usual case from my experience. There's at least 2 systems. Usually there's SAP involved, and then maybe also a product information management system, a PIM, where you get product metadata from. And in the next phase of the project, we took this metadata model, the mind map, and implemented that in Ixiasoft. And then you need to consider which mechanism your CCMS offers for implementing metadata. And this is different in every CCMS that you're using. So the actual technical implementation of the metadata may vary from case to case. In the case of Ixia, we used DIDA mechanisms, of course, for instance, profiling attributes to differ between product variants. And we used subject scheme maps to define the allowed values for the metadata. We also used metadata elements in DIDA topics, and the controlled values are stored in topics, in the metadata definition topics. And when it comes to information products, the colleagues used DIDA files to actually distinguish between different variants of documentation. So these are all standard DIDA mechanisms that are used in Ixiasoft. iiRDS in this use case is the blueprint for the metadata model. We used a lot of the standard classes, but also some custom objects for Danfoss. And the technical implementation in the CCMS is out of scope for our iiRDS and is specific to the CCMS, in this case, Ixiasoft. In one of the next project phases, hopefully, we can then implement a transformation so that, because Danfoss hasn't bought a content delivery platform yet, but they are going to do at some point in time. So what we can do then is from Ixiasoft, take the DIDA files, and then generate an iiRDS package, because all the metadata are already based on iiRDS, and then we can take that iiRDS package and put it into a content delivery platform. But this is not due for some more months, and maybe we will present the continuation of this project at the next TC World conference. So what did we learn in this project? iiRDS is a very useful blueprint for defining your metadata model. This is even more true because it provides definitions of all the metadata classes. And in the latest release of iiRDS, which was in November this year, they reworked all the definitions in iiRDS, so they're even more easy to understand now. As I said, the actual technical implementation of the metadata model depends on the CCMS. And something that is very typical of such transformation projects, when you go from documents to topics, and when you go from generating information products, documents, to generating smart content, is that you need a training and ramp-up periods for your technical communication department, because they need to know, they need to learn about metadata, classification, about topic-based writings, how the CCMS works. That's all mainly independent of iiRDS, which is a feature of all those transformation projects. Another thing is that usually the technical documentation department needs to stay productive. So they still need to get documentation out there because the company doesn't stop producing or manufacturing. So what we focused on in the first project phase is actually the variant defining metadata, so that the technical writers were able to still produce information products for their product variants. And in the background, you can continue migrating content, but you need to make sure that the technical writing group can still deliver products. Okay, and now we go to the next use case. Is there any question about, do we have any raised hands? Just a second. No question, I don't see any hands. So, Achim, you can start, I think.
Yeah, can you see my screen?
Yes.
Okay. So, combining knowledge graph and generative AI. I mean, we only have a limited time, and this topic we could talk the rest of the day about the generative AI hype. But everyone playing around with it has seen some problems, which are more or less a blocker for productive use for industry companies. And well, it's hallucinations. I mean, the self-confidence of this piece of software to just lie about things is really impressive. But this is the main reason why you just can't use it, because you can trust the information, and it's really annoying, especially if you want to use it for a demo, that you're querying with the same string 4 or 5 times and you will get different answers every time. The expensive training costs, this might change in the future, but at the moment it's just not feasible to train your own model with your own knowledge, and even fine-tuning is it's really expensive, and on our expectation it's not just not worth. These Gen AI components, they are built to give answers. They are not prepared for access rights for information, to look who is asking and what kind of information is suitable for him, which kind of information he is allowed to see. And even more important, it's not possible to train it to forget information because, well, it's a statistical approach. No one really knows where the facts and the information is stored. So there's also no possibility to tell those components, well, this information is not valid anymore. Please don't provide it as an answer. And all these problems lead to a different kind of process which has to be implemented when using a Gen AI component, and it's called retrieval augmented generation. And as you might remember, the first slide with a statistic AI on the left and the symbolic AI on the right, now it's up to date and fancy again, because it's a combination of statistic and symbolic AI. It's the usage of knowledge graph, it's the usage of facts and reasoning capabilities. It's the pre-selection of content to ensure that only up-to-date knowledge is used, to offer some real reasoning to chatbot UIs, because also everyone knows it's really impressive what those Gen AI techniques can provide as result, but they are not able to calculate. They are not able to give a result for even the simplest mathematical questions. And it's not only the usage of those traditional AI techniques, it's especially the uses of the possibility to create embeddings out of modular topics, and even more important, the iiRDS metadata to generate embeddings describing the content can be used to calculate semantic vectors to discover semantic similarities between topics and the query of a user and the result of the topics. So what we're doing at the moment, in those chatbots scenario, when a user is sending a request to a question and authoring system, it's not sent to the large language model immediately. Instead, the query goes to a knowledge base using all these techniques like semantic search, like natural language processing, like knowledge graphs. The knowledge base filled with info products, with topics, with articles, with small chunks of text and not full-fledged documents, probably also decision trees. And with all these traditional techniques, including the similarity search of a large language model, we are, for example, able to ask clarifying questions. Probably looking at the question of the user, we found 50 topics where the answers might be included. And we can also see they can be separated with asking for a product variant, because they all have a different product variant metadata. So we know, okay, it's perfect to ask for the product variant, because then we could limit the set of possible results. We can do this as long as we just have 4 or 5 possible topics left. And those 4 or 5 topics then can be sent to the large language model, can be used to choose the appropriate prompt template and just tell the large language model, these are 5 topics, there's the answer. This is the target group, this is the kind of information, the topic type. Please generate a nice result and give it back to the user. So all these stuff like entity and pattern recognition, like the natural language understanding and the case-based reasoning, especially the knowledge graph, these are crucial and very important techniques and pre-processing functions which have to be used to get the trustworthy, to get the quality of the information. So a company is able to provide a GenAI-based chatbot to their end users. This is just an example. As I said, those live demos can be really tricky, so I will do it with some screenshots where all of this is used, where the natural language understanding, the ontology, the knowledge graph, and this semantic search is used. And as a real example we've done with an industry company, I can present you 2 screenshots from KUKA, German manufacturer of industry robots. Ulrike and we, so Parson and Empolis, we do have some more customers. We are implementing scenarios like this at the moment. We're just not allowed to talk about. So if you want to know a bit more about more details, probably about other branches, just contact Ulrike or me afterwards. So KUKA. And here you can see what I meant with the usage of the metadata. I mean, how do I change oil on axis 2 in my KR 2000 series robot? The real game changer for this retrieval augmented generation is the immediate question, could you please specify the exact model of your robot? There are different models. We know, okay, yeah, we know how to change oil, but changing the oil on KR 2000 series, we still have 10 topics. And we do need the serial number, because that's the way to distinguish these topics. And the semantic similarity is really large, because probably just a small amount of numbers or instructions are changed. And with not having the information about the actual serial number, we are not able to choose the correct information. And that's the reason why we ask, or why the chatbot is asking the user, please give us the serial number. And once the user provided the serial number, we know which topic has to be presented. There are still 2, 4, 5 topics where the information is located. And these 5 topics are sent to the GenAI component, and the component is producing an answer and also giving a reference to the documents if the user is not sure and wants to see it itself. So iiRDS, the metadata, is the most important part of an information flow if you want to establish a GenAI-based user interface for your end users. Because only iiRDS and the metadata is able to deliver the necessary information provided by the authors. And the metadata is more important than the actual content for generating embeddings. What you've written is just used as a source for generating an answer. The metadata you annotated to your topic is the key success factor for the quality and trustworthiness of the information. And what we've seen, the standard vocabulary of iiRDS is perfectly helpful for the prompt generation. So if you have the plan to get rich as a prompt engineer, have a look at the iiRDS metadata, documentation type, product lifecycle phases, document types. These are the kind of metadata a GenAI component can use to generate special kind and flavors of results. And the general learning from the project, impressing capabilities of these chatbots, but the trustworthiness of the answer is just not enough to offer this as a service to customer. Fine-tuning, training of your own model, probably 2025, but not at the moment. And using all these topic-oriented writing, using all the metadata, and probably also in a knowledge graph, increases the quality of the answers significantly. So one thing is the metadata, the other thing is the topic-oriented approach. So one topic is describing exactly one aspect or task. And what we didn't expect, but what we learned in the projects right now, the usage of the metadata to send clarifying questions to the user, to filter the set of possible results, and to use special classes for the prompt generation. Ulrike?
Yeah.
Your turn.
Taking over. Any questions in the room?
Not yet.
Okay. Where's my mouse? There. Does it work? You see the screen?
Yes, we do.
Okay. So let's have a look at the 4th and last use case. And this is a bit complex, so I hope we get it across. It's we go once more back to generating technical documentation, not delivering, but in the authoring phase. And there's this report from a project where we use the knowledge graph to actually generate technical documentation. So this is from Enders and Hauser, and if you attend the TC World Conference, we've reported about this project several times, and there's also some videos available on our YouTube channel about that. I'm probably in German, I'm sorry about that, but I give you a summary. So Enders and Hauser had the requirement to switch from their documents, which again apply to a whole product family, to documentation that actually fits the delivered product variant and a delivered product configuration. The problem is that their products are highly configurable. So it goes from like the length of tubes to the material of switches. And this and on this depends the certificate, whether you can apply, they do flow meters and switches and all that stuff for the industry, for the processing industry. And depending on the properties of the product, you can then use it in different environments, for instance, for food processing. They do have a CCMS, but assembling the correct information for specific product configuration was very challenging, and their CCMS was not up to the task. So they decided to switch that and to move their documentation from documents to topics and semantic content delivery, and decided to switch to a knowledge graph in order to manage all the product knowledge that they have about the variants and configurations that are possible, and then use that knowledge graph to trigger the generation of technical documentation. And the documentation format was switched to DIDA as well and moved to a DIDA CCMS. We are still in the middle of that process, but what we already have is the knowledge graph component, and this works very well for assembling all the information that you need. So in the knowledge graph, we have two types of model. We have an information model, which is like the information classes for the technical documentation, and we have a product model. I first show you the information model. So this is a web view on the model, but it's actually a graph, just like Achim showed before. And the taxonomy that you see here is represents categories for technical documentation content. You have some main categories like safety instructions, general notes, technical properties of the products, and the largest category is oriented along the phase of the product life cycle, so that you have information for purchasing products, assembling, configuring, operation, and so on. You know that when you work according to the machinery directive, this is the usual organization of content for technical documentation. This knowledge graph or this model contains all the nodes that need to be filled with topics once a product documentation is going to be written. So when you have an Endres and Hauser product that has an electrical connection, then you also need to say something about the degree of protection, or you have to describe the connecting requirements. The nodes here in the model, they have iiRDS-based metadata. They have, for instance, something like the topic type, phase of product lifecycle, and action, and these are all standard iiRDS metadata. Every piece of content, every topic that we write in DIDA belongs to one of those nodes and inherits all the metadata that are assigned to this node. The second model that we have in the graph database is the product model. There you have representations, and this is not Endres and Hauser. What you see here, this is a generic model because we didn't want to show their information. So what we have in the model is the product variants, product families. For instance, these are excavators, and the power mole is one product variant within the excavators. And those products have properties like safety equipment. There can be different types of different properties for the safety equipment. You can have a safety belt, you can have a safety grid, but you can also have a lever for locking the servo controls. And what the information architects do is that they say, okay, this property and this value defines a documentation variant, because you need to write different content depending on whether you have a lever in the machine or whether you have a safety belt or a protective grid. So that's different information. So there's a little check mark at the property and at the value saying, okay, this defines documentation variant. The product information comes from different sources, which is also kind of a problem because they are, of course, differently defined. and we get in information from the product information management system, from SAP, and from software configuration databases. And now we put those two together. We put the information model together with the product model. And to do so, we have a middleman or middle person, which we call variant selection. So when we have in the information model, which is kind of structure for our documentation, we have something about safety equipment. Then we connect that with the variant selection, which is also called safety equipment. And this variant selection is connected to properties from the product model. And this variant selection indicates to the mechanisms that we use, okay, if my product has a safety equipment, I need content here and at this place in my information model. And if Enders & Hauser introduces new products with other options for the safety equipment, we just add product properties to the variant selection. So we don't need to maintain the model all the time. We just need to add properties or remove properties. The variant selection stays stable and can be used for controlling the collection of information modules. So this is something that the information architects have to do in the beginning, and then we can go into actually assembling documentation from that. The mechanism is called editorial assignments, and I would compare it to a project, a documentation project. So imagine you're a technical writer and you're an engineer or product manager comes and say, okay, we do have a new product, please start the documentation. You can start with, for instance, the basic safety instructions, or you can already write something about the assembly. And we have already entered the product information in the PIM, so you can go ahead and start. And this is what the task managers do. They go and start the editorial assignments and say, okay, I want to write something about basic safety instructions. I select those nodes from the information model. Then I select the product configuration, and this selection contains all the properties in the background that are configured in the PIM, in the product information management system. And then those two, the info model and the product model, are analyzed, and the knowledge graph shows me all the information units or topics that are already in the CCMS and are talking about safety equipment. Or if it doesn't find any modules, then it creates empty information units, because we obviously need to write something about the safety equipment. And here you can see from the screenshot that this machine, that the power mole that I selected there, has different types of safety equipment. It has both a belt and has also a grid. And that's why we need to create two topics here talking about that. So this is how it works, basically. So this editorial assignment is transported to the CCMS, and the technical writer gets the assignment, and all the information units that are in there are either already filled with content or are empty, and they can start writing immediately. They don't need to assign any metadata, because the metadata is transferred to the information units from either the information model or the product model. So there's no metadata assignment necessary in the CCMS, which is a huge deal, because tagging content with variant information can be cumbersome in CCMSs. The technical writers can solely focus on their task for creating content. The role of iiRDS is such that iiRDS is actually the fundamental or the underlying data model here. We have two components in the solution. We have the information management, which is the information model in the knowledge graph, which holds all the metadata. And we have the DITA authoring environment, which uses the metadata and where all the content is created. And once we have completed, we are in the middle of the transformation, we will use iiRDS to actually deliver content to a distribution service. This is not done yet, but this is planned. So iiRDS is in the authoring, in the data modeling, it is used for actually mapping also the product data to iiRDS metadata, and will also be used in the delivery. So it's a full application of iiRDS. What did we learn from the project, or still learning because the project is ongoing? With this approach, the technical documentation starts with the product data. So you need to have a product configuration, you need to have the product properties before you can actually start writing, because the editorial, the assignments, the documentation projects, they rely on the product data to be there. And this is difficult because in real life, the product data is filled by and not at the beginning of the project. Also, another obstacle or a challenge, let's put it like that, is that the product data comes from different sources. It lives in different silos, and of course it has different granularities and definitions. So we have at least 4 systems connected here. We have a PIM, we have a SAP, and we have 2 different software configuration systems. We import all that into the knowledge graph, and we use the knowledge graph for mapping and harmonizing this data, which is a lot of work, but the knowledge graph is a very useful tool for that. Also, the customer is moving from documents to topics, which means we cannot simply take the old documents and put them in a system. We have to rewrite the content, and we have to restructure the content. There is no migration path except for translating one XML definition to another. We need to chunk the topic in into different pieces, and then also because we are now writing specific to a product variant, we need to actually create more content. The knowledge graph itself is independent from the CCMS. So you saw that the information model and the authoring are different. So you could also exchange the CCMS that's actually used for authoring in the lower part of the window that I showed. Such transformation projects take time and cost a lot of effort. So this has been running for 3 years, and it's still ongoing. Okay, we do have questions.
Yes, we do have a question now. So I'm going to read out it to you. So the question is not so much related to the use cases. So it's a question from someone who is going to start a data migration. And the person asks how one can see the graph of the iiRDS for, excuse me, where is it again? So the person asks, how one can see the graph, for example, for the iiRDS for machinery. Is it possible to see it in a graphical way, to see the tree of an iiRDS standard in a graphical way and not just the XML structure, which is not so easy to work with? Or does it have to be recreated with software, such as Xmind, for example? End of the question.
I can start, Achim, and then you can continue. So iiRDS is what the consortium delivers is a RDF schema, so it's an ontology definition. What you can, and this is expressed as XML. There are other expression formats for this. What you can do with that is to put it into a knowledge graph software that is able to understand RDF, and there are several on the market. If you want to use something free of charge, use Protégé, which is a very simple ontology editor and viewer. If you are able to pay money, you can use a software like Pool Party. You can use the knowledge graph component from Empolis, and you could also use, what else is there? OntoText, for instance, which is, I think, also able to interpret RDF. And then you usually also have a graphical way of seeing the metadata or the ontology. Achim?
Nothing more to add. I mean, probably the documentation on the iiRDS website offers some good introduction. You don't have to look at the RDFS to find your way through all the classes, description for any class, use cases, examples. And yeah, Ulrike, as you said, there are open source visualization tools or quite a lot of commercial tools to visualize the iiRDS structure. But first approach would be the documentation of all classes and objects on the iiRDS website.
Mm-hmm.
Okay, thank you so much. I have also another question. So what, in your opinion, would be a good way to train students, to prepare students to use metadata or to use iiRDS in their careers, in their future careers?
Well, I think at the moment everyone thinks no one needs him in a few years because Gen AI components will take his job. And I think it's obvious that this won't work, and that the usage of metadata and being familiar with annotating content with metadata is the game changer for the trustworthiness of these Gen AI-based chatbots. So if they want to survive, they will have to learn it.
Yeah,
Thank you so much. Yeah.
I think that if you want to use iiRDS and metadata in general, you should learn something about knowledge modeling in general. What are ontologies? What are taxonomies? What is metadata used for? And also try to understand knowledge graphs. Because one of my hypotheses for technical writers is that we will become more like knowledge modelers or knowledge engineers. Because as Achim showed, that generative AI solutions can work quite smoothly with structured data. So changing the tone of voice or just summarizing something based on based on some facts, that is something that a large language model can do. But somebody has to state the facts, and somebody has to create the knowledge that is given to the language model.
Exactly. Yeah. Thank you. Also, thank you for answering the other question.
Yeah, there was one more from Fabienne. For all use cases, do the knowledge graphs have been developed manually? It's a mixture, actually. So we have, as we said, we have plugged in some external sources like a product information management system. But the information model that I showed you for Endres and Hauser, this was done manually, but part of the product model is built up automatically because it comes from external sources. It is always a good idea to have a general product model on top and not just rely on the data sources when it comes to the product models. Achim?
Yep.
Okay, and there's one more about the DITA use case from Ted. Metadata annotated directly in the topics against using a semi-automated method like the Open Toolkit to assign metadata externally. When do you want to keep the metadata directly in the topic versus reference externally? Yeah, that's an interesting point because it depends. From my perspective, I would always keep the variant defining metadata internally with the content in DITA, either in the, you can use, I don't know, classification maps, or you can use the metadata elements in the topics, or the attributes, the conditional attributes, or profiling attributes as they are called. This is good because that if once you want to generate an information product, you can use those metadata to actually define the documentation variant. And then there is metadata. I personally think that you don't need in the content. And this is metadata that you only add for content delivery. And you could add that by other means. You could, for instance, assign metadata to a map, and then all the topics inherit the metadata from the map. Or you can use an external classification system like Plus Meta or Pool Party or the Empolis software to actually tag content with artificial intelligence. So that's in my head, this is the distinction that you need some of the metadata for variant management, and this should be with the content, but the other metadata is only there for future use of the content, and you could add it another way. Okay, shall we continue with the lessons? There are no other questions. My screen is still on, right?
Yes, it is.
Okay, so lessons learned. iiRDS has arrived in the industry, I would say. It is an established standard. We have various projects using the standard because it's a very good basis for structuring content and for setting up your metadata model. But it can actually be much more than that. It's much more than a metadata vocabulary, because in combination with knowledge graphs, iiRDS can be used as a starting point for an extended metadata model, but it can also be used for mapping and harmonizing data from different sources. You're very flexible how you want to use iiRDS. You can just use the metadata, but you can also use the delivery format or the mapping capabilities of knowledge graphs. In every way, and in each way, iiRDS paves your way to smart information, to smart content. And smart content is a very good basis, as Achim demonstrated, for using Gen AI like ChatGPT or another chatbot interface. What we've also seen in the project is one of the main motives for using iiRDS is avoiding a vendor lock-in for either your authoring system or the delivery system, because it's system independent. Achim, shall I just leave my slides on and you read the second one?
Please. Well, iiRDS always needs to be extended with product metadata. Yeah, it's in most of the project, it's the case. Because iiRDS only provides stocking points for product metadata, because everyone is modeling its product data on its own. And it's a standard for technical documentation and not a generic product modeling ontology. So most of the time, you have to connect your own product model, or you can use the generic classes, which is also okay if you don't have a product information management system yet. The knowledge graphs, they are not only useful for maintaining the metadata models, they are not only a fancy marketing instrument because it looks nice when the graph opens and you can navigate. It's the state-of-the-art technique, state-of-the-art model for harmonizing data from different source systems. And especially the product data in companies is usually spread over several silos, and it takes some time to form a product data model useful for product development, useful for product engineering and documentation. But this is the problem you will have to face anyway. If you want to combine your documentation with all those product variants, you have to do this work. And iiRDS gives you a perfect guide to achieve it. Transforming technical communication from documents to topics takes a lot of time and effort. Yes. It's not easy to switch from this document thinking to modular topics. And as Ulrike stated, most of the time you have to completely rewrite your content. It's not just an XSL transformation to transform it from one XML standard to another. It's new work. But the setting up of a content supply chain for technical documentation and product information requires participation of more than just the technical writing. The technical writing is the perfect starting point. They are the most important part on the way, but they are only the first. And people from product model, people from service departments, people from used to deliver information, and they have to join to establish this route, this way. But iiRDS can help to bridge the gaps between these different parties involved in a content lifecycle chain.
Yeah, it's interesting how the project changed. We now almost every time have the product data management, or the product management in the project. Usually before, when we introduced the CCMS, we just had technical writing. Now we also need the product data management team.
Yeah, there is one question again. From the MM to RDF, you need a converter. I'm sorry, I have no idea what MM means. Probably
Neither
yes.
have I.
Sorry?
Yeah, neither have I, Fabienne. Mind map.
Mind map.
The mind map was just a tool for discussion. You don't need the mind map at all. We used the mind map because we didn't have a graph database in the Danfoss use case. We just used the mind map to explain the metadata model to the customer.
Yeah, and as at the end of the day, a mind map is usually stored as an XML file. Yes, you would need a transformation to RDF if you really want to use it as a source for your metadata model.
Yeah. Well, it's actually just a working instrument in this case. So if you have more questions, feel free to contact us. And I also listed some resources here. iiRDS has a website. There's where you can find all the specifications. Everything is in English. You just have to register at the website. There's a YouTube channel where you can find this webinar and other webinars. And if you want to visit our website, we do have a lot of resources about iiRDS on the website. And I think this concludes the webinar.
Yeah, so thank you so much, Ulrike and Achim, for sharing all this useful information with us. It has been highly informative and insightful, and also the links to the resources. So we also refer to the other two webinars that were held before on this topic of iiRDS. So if people are interested, they can also have a look into our webinar library. Okay. Thank you also to the audience for participating today, for being with us, and for asking your questions. And thank you, tekom Europe, for organizing this webinar.
Birgitta, there are some more questions in the panel. Can you?
Yes, I didn't see any new ones, but perhaps while speaking, let me just have a look. Yeah, will the slides be available after the meeting? Well, there is a recording, as far as I know, and there you also have, access to the slides, obviously. But I don't see, they don't come in chronological order in.
No, I think the rest is fine. Yeah.
They've all been answered so far, and also in the chat, I don't see any questions.
No. There's one question left. Is the white paper
regarding the white paper? Yes, I just saw that note, Suzanne here from the iiRDS office. I just saw that note on the iiRDS white paper. It is available in English for download. Let me just check if there's anything wrong with the download, but it should be available there. When on the main page on the iiRDS.org, page, it is available in English. That's the main download on the site, and then you have the bubbles on the bottom where it just mentions additional white paper languages like German or Japanese. But on the top, I think somebody got confused on the iiRDS web page. It is the main download is in English, and then further down you see the German and Japanese language versions. But it is available on the main page there as well in English.
Okay, then.
I'll just check.
Saying I can download German but not English. Just
Susanne can contact the.
I'll check if there's a technical issue with this. Otherwise, yes. Otherwise, just because I might not have your contact details, I'll drop an email there, and just let me know. I'll just note my email. Just write down my email address, and then you can drop me an email so I have your contact details, and I can walk you through the process.
Okay.
Great, thank you.
All right.
Thank you very much. Have a nice Christmas, everybody.
Yes, you too. Bye-bye.
Bye-bye.
Thank you once more. Bye.
Thank you all. Bye-bye.